Good morning, everybody. Welcome back to lecture number 41. Let's continue the discussion about the distribution lines. So, last time we talked about the radial, and in the radial we have lateral phases, A, B, C, whatever, single phase components, because they are used in rural areas mainly. If you have an adjacent feeder, if you want to power it more, you can close this normally open switch and get the power from the substation. Okay? So that's the benefit of radial, is that you can extend it to a further neighborhood that is powered by another distribution line. And usually we add capacitor banks Y to improve the power factor, cosine theta. If we improve cosine theta in Ma'iri, it means we make theta of I closer to theta of V, because theta is theta V minus theta I. If you make the thetas close, if you do complex numbers, this will increase the voltage levels here at the further areas from the substation. And what was the allowable minimum voltage? The Saudi standard? 5%, plus or minus. Don't forget this number. I will ask you in the test. What's the minimum voltage allowed for 13.8 kV distribution? You have to multiply 13.8 times 0.95. That's a minimum. Clear? These are things fundamentals. You cannot work with Aramco, with SEC, with principal buyer. You know the principal buyer? No. You know the principal buyer? Anybody knows the principal buyer? Principal buyer المشتري الرئيس. It's a company in Riyadh where they coordinate.
شركة سعودية.
Yeah. تبع وزارة الطاقة. They buy the power and sell it and make sure Saudi Electricity Company and Aramco, whoever generates power, Aqua Power, they're all agreeing with the fair prices. What else we have? We have the loop system. What is the beauty of loop system? If a fault occurs here, this recloser will be open. Then if a fault, this recloser will be open, it will not close. Even this breaker will be open. So these two loads will be of service. So the center would close the normally open switch. We call it tie switch. And we tie these two loads to the feeder number 2. We'll ask you in the exam, explain. Okay? It's very fundamental. Very few electrical engineers know the difference between radial and loop. In the old 360, they never taught them these things. The underground here, the difference is we don't have recloser. We have what? Switches. Why? Because of the recloser. I told you how it works. There is a fault, close. Wait a few minutes, open. Wait a few cycles, open. Close. Open. Close. Open. طالما الfault there, it will remain open until somebody manually closes it. If you put it underground, are you going to dig into the ground to just reclose the recloser? Then don't put it. So true or false? We put recloser underground.
False.
Stupid. Okay? In underground we put switches, but these switches for if there is a fault that occurs in the ground, these switches would minimize the permanent fault. Because faults underground are permanent. They're more dangerous. And I told you the network system provide higher service reliability, quality than both radial and loop. It's typically found in big cities, downtown. Primary network consists of a grid of interconnected feeders supplied from a number of substations. Faults on interconnected grid feeders are cleared by circuit breakers as distribution substation, and in some cases by fuses on the primary grid. And I was telling you, substation here would have breakers. The substation has breaker. The substation has breaker. The substation has breaker. We have radial line. They all count as a loop in a network. Maybe if there is a fault in this load, this breaker will open. This fuse will burn. قلنا الفيوز يحترق مرة واحدة. خلاص. Blow up and stay open. The breaker, it can close. So this breaker, they may put it above the ground. Okay? Then we talked about secondary distribution, voltage levels, where they distribute energy at customer utilization voltages from distribution transformers up to meters at customers' premises. I want to test your knowledge. Is 240 line to line and 120 line to neutral? Yes. Who said yes?
No.
You should not get errors.
بس الرقم هذا أحسه أكثر شيء يكون فيز.
أحسه is something, or I know is something else. You did not read the information.
أيوة single phase.
How many times I tell you we don't have line to line for single phase?
طبعا أنا أقصد إنه هذا single phase يعني.
This table is made for smart people who study 360 hard. You're smart, but you didn't study hard. You never have line to line in single phase. So he's actually telling you these are two different voltages.
طبعا أنا أقصد إنه هو single phase هذا.
Yeah, but my question is this line to line and this line to ground. You
لا،
say
هذه
it.
كلها ground.
So two different voltages.
طبعا 240 120 معروفة. اللي في الجدار.
They asked, is it single phase or line to line? You said line to line.
أنا أقصد لا، أنا أقصد إنها phase مو line to line.
And you said line to line. We can watch it. If you said phase, I say that you're smart and you study 360. You're smart either way. But single phase is always line to ground. How about these 208? Divide 208 by square root of 3.
120.
Divide 480 by square root of 3. Get it? So these are three phases and we have to tell them this is line to line, this is line to neutral. But these are two different. How do we get these two? Basically very simple. You put a transformer, maybe here 440, another winding here, this is 480, this is 240. If you take center tap voltage, that's 120. Get it? So for residential in the kingdom now it has to be around 240, line to line, line to neutral, single phase. For three phase, it has to be 208 Y connected line to line. In the kingdom, we actually increased it now. It has to be 220 before three phase. It depends, 210, 220, but this 120 is not the 120 we have here in the old. This is 110. This 110 is line to line. So we have 4 wire, 3 wire. Industrial load, they have higher voltage, 480.
دكتور الفيش line to line ولا line to phase؟
Line to line. No. Line to ground, you're right. Because it's single, this is single phase. So maybe this classroom is phase A, the other classroom phase B. We don't know.
دكتور الحين القيمة الثانية السنجل فيز وش تمثل؟
Two different configuration, 120 or 240. بس هذه line to line. هذه line to ground. This is US. This is US table. So in the kingdom, it's this and this should be 220. So multiply by square root of 3. 220 line to line, RMS. 220 line to ground, because it's single phase at the outlet. Clear? Last thing is power quality. Let's look at this. We have a substation. We have the feeder. First customer have transformer. This is from primary to secondary. And the first customer has around 125 volts. So the ANSI standard, this is US, is 126, 114. It has to stay within this band. So 126, so here it gives you 125. There is a voltage drop here. And then And then we have what else? We have the first customer at this load, 3 volts primary feeder. Across the primary feeder we have voltage drop. Then we have another voltage drop, 3 volts for distribution transformer. What does that mean? How to read this figure? Here, before the distribution transformer, we have this voltage. Add 3 volts for distribution transformer. This is distribution transformer. Add 3 volts. Be here. The first customer is okay. If you go to the last customer, add distribution transformer drop.
هذا السكند.
You'll find the second customer. Yes, this is here. يعني يقول لك هنا first customer حطها الدائرة هذه. The problem comes at the last customer, where the last customer lost the primary feeder, distribution transformer, secondary and service drop, and internal wiring 4 volts lost. So it's below the 114. So the last customer is at danger. Because this is a bad design. That's why here we need to have capacitor bank.
Okay.
If we have capacitor bank, we'll increase the voltage. What I'm telling you is count for voltage drops. 3 volts for primary feeder. So the full length of the primary feeder will drop 3 volts. If you only go this area, you will drop this voltage. If you're middle house, it will be here. But also you add distribution transformer, which are these. You also need to add secondary and service drop. Secondary. You also need to include 4 volts of customer wiring. So maybe customer 1, customer 2, they're all going to be fine. But the last customer,
تمثل الفولتج ولا تمثل الباور؟
no voltage. Secondary voltage. The y-axis secondary voltage. The x-axis is distance.
طيب كيف اعرف اني فيرست كاستمر ولا سكند كاستمر؟ لانه ما لي علاقه بالديزاين.
Well, you should, you know, they know. Keep in mind these are permanent projects. So when they put it, they know how much this land or this house will have a voltage drop. You don't need to know everything in detail, but you need to have a sense of, we have 3 volt primary feeder, we have 3 volts at distribution transformer. We have a 3 volts secondary and service drop. And then we have customer wiring voltage drops. So the first customer might be okay, the last customer maybe will be okay, but with some parts of his house will be below because of the customer wiring.
استغرب الهاوس اخر كاستمر صح؟
What I want you to know is the first customer, okay,
مين هذا المحبوب؟
هذا الفيرست كاستمر عنده 4 voltage drops internal wiring. عنده his home has better voltages عند طبلون. بعدين عند last wiring 4 volt drop roughly. The third last customer ممكن يكون وصل له الفولتج اوكي بس عنده في الطبلون بس عنده بعدين 4 voltage drop في الواير.
دكتور الحين المطلوب 110 فولت صح؟
This is US.
المطلوب 110 طيب المفروض لاست كاستمر افضل شيء لان عنده 110.
No, it should be 120 ideal. This point should not exceed ANSI limit. والمثلث should not يعني الدائرة هي باند. الدائرة لازم ما تعدي 126 والمثلث ما يقل عن 140 114.
طب دكتور الكابسترات فين يمكن تنحط عشان يرفع الفولت؟
And next to the service transformer. In parallel with transformer.
انبرر مع ترانسفورمر؟
Yes.
طيب ال 3 فولت وال 4 فولت هذه ستاندرد؟ لا
No, this is estimation, not accurate. يعني primary feeder across the line you will have 3 volt drop. Distribution transformer, which is this and that, will have 3 volts. Then secondary and service drop piece, يعني secondary another transformer before every house will have another 3 volt drop. Then the internal wiring will have 4 volts. Clear? Clear? Enough about distribution. Before we proceed, I want to tell you about how we connect everything. So here if we have synchronous generator, module what? 5, connected to a transformer, module what? 2, to transmission line, module 6, to transformer, module 2, to a load, which is generic, ما في load. He's telling you this load maybe 10 MVA, 0.8 lagging power factor. He's telling you this is 13.8, so you know what's the transmission level voltage? 100 times 13.8. That's 100, 10. 138. Okay? Clear?
اوكي.
So A is 10, this would be 138. This is 1 over 10, so what's the load voltage? 13.8. Okay? Here you draw the synchronous generator, here we have EA. What is VT? 13.8 divided by square root of 3. Why? Because this is the nameplate. It's VT.
يس.
Okay? The E sub A, depending overexcited, underexcited, etc., it has to be calculated. So maybe I tell you in the exam, IA maybe I don't know, 50 amps.
هذا الريتد.
Let's say rated. Everything is rated. The question is, what is IP? IP is IA.
Yes.
Maybe I can tell you synchronous generator EA has a voltage. This has a voltage. You calculate IA. How to calculate IA? EA minus 30 VT over this impedance. Okay? What is VP? VP of this transformer is 13.8, is the VT of the synchronous generator. So I know this, I know that. I can calculate VS prime. But the trick here, if I calculate VS prime, I get also IS prime. The trick here is the transmission line, the pi model, has an input, we call it, we should have an ideal transformer here to convert Vs prime equal VAVS. And here we have Vs, which is V sending, equal to V secondary of transformer. Clear? So here I need to have V secondary equal V sending in equal to Vs prime over A. Because this is isolated. So the output of the transformer is Vs prime is the input for the transmission. Vs, not Vs prime, don't put Vs prime as the input because Vs prime is in the order of 130s. But the input of transmission line has to be the input of the input of this transformer. Vs prime is maybe 13.8 or 14. The input here has to be 138 or something. So you do the calculation and you put it as the input of the next stage. Then you go here. What is the input for this transformer? VR. After you calculate the pi model, which will be the input of the step-down transformer, where we have here equal to VP. Here we have Vs prime of this transformer. You connect it to load. Maybe I'll ask what's the efficiency. It's P output over P input times 100. What is P output? 10 MVA times 0.8 divided by P input. How to get a P input? Is the P input of synchronous generator, which is a 3 EA IA cosine of theta EA minus theta IA. The input power حق synchronous generator. Then I can calculate the efficiency. Let's say everyone has 90% efficiency. 90 times 90 times 90 times 90. How much? In the order of 65%. Clear?
لازم يكون أعلى من 65.
No. Roughly, تقريبا. Maybe 50, maybe 70.
بس هذا good ولا bad؟
Bad. What can you do? You have stages, different stages. What if I ask you in the exam, transformer and transmission line, and I ask you to connect both of them? Or I give you synchronous generator and transformer, and I tell you what is Vs prime, what is Vs. Maybe I add 1, 2, 3. What's the receiving end of transmission line?
So reflect.
You have to. If you want to get the A plus and the A, you have to study hard.
دكتور كيف نسوي الترانسفورم الثاني reflect الأول؟
عادي مش reflected. قلت لك أنت your output is Vs prime. The input of transmission line
multiply by
is what? Is VP. is Vs, which is Vs prime over A. Clear? If you want to get the A plus, you should know how to solve this example. Maybe I'll bring you all of them. Well, it's possible. But do you understand what to connect? The output of the first stage is the input of the next stage. The output of the transformer is not the input. You have to reflect it to secondary and then put it the input for transmission line. Clear or not? Okay? So in a nutshell, I'm not going to start the converters today. We'll start next lecture. Module 1 talked about what? 3-phase, input power, complex power, which is P plus JQ, delta and Y. Module 2 talks about what? Magnetic circuits and transformers. We talked about equivalent circuit, circuit 1, circuit 2. Module 3 talked about DC motors. Module 4, induction motor. Module 5, synchronous generator. Module 6, GLs. Module 7, distribution lines. And module 8, we'll talk about power converters. You can call them PCs, it's up to you.
Is there what do you mind or anything the last one?
Module, we don't have module.
قلت له الدي سي جنريتر مو معنا ما راح اخذه. طب هو كان من زمان موجود ولا مو موجود؟
Come on. DC generator, we did a little bit in the homework. It's the problem. You solved the homework.
موجود في اللاب.
But I'm a student at 361. I'm not teaching 361. It's 2 courses. Also DC test, plugged rotor, we did. You need to understand that the lab is separate. Who is not taking the lab is separate. Clear? So please, have this idea in your mind of such problems in the final exam. I'm giving you a warning because you really need to understand.
كم بيكون علينا الجواب؟ بيكون ثقيل كثير.
Maybe 30%.
كثير دكتور.
Yes, do you want to get A plus?
سؤال سؤالك الفاينل يا دكتور؟
I'm not gonna bring all of them. Maybe two circuits.
طيب تحط لنا دكتور أسئلة نجاوب عليها إن شاء الله.
Maybe I will put exercise. Remind me.
طيب هذه دكتور قلت C over 2 ولا Y over 2؟
Well, it's you should, for transmission line you have to calculate Z, you have to calculate Y. So here it will be actually Y over 2.
طيب والمعادلة اللي فوق BS prime equal BS prime فوق.
No. A Vs prime equal to A Vs. So this Vs is the input of transmission line. This Vs prime is the output of your transformer, if you refer it to primary. If you refer it to secondary, then your VP should be reflected. So this 13.8 or so should be divided by and get VP prime. It's your choice. To me, if you are not able to solve such problems, you did not learn. Because nobody in real life will ask you, oh, give me the model transformer. He will tell you, here's the transformer, here's the generator, here is the transmission line. Give me losses. Estimate efficiency. Are you going to say, oh, I'm not going to do it, I only do one problem? Then they will probably fire you from the job.
إيه بس بالترى
And then you will not have a job.
اللي تقول لي زي كذا تقول لي بروجكت اشتغل عليه زي الناس وقت كافي مو زي الاختبار ساعتين فيديو.
Okay. For you, this is your project, design. And give me efficiency not smaller than 65%. And then, in the exam, I'm gonna give you other questions. You want to have that?
خلينا مع الجماعة أحسن.
موت مع الجماعة. Seriously, if you want this to be your project, you can do it. And I will not ask in the final. وش اللي مو نفسه يا فاضل؟ وش اللي مو نفسه؟
لا أقول بس أنا أسأل يعني كيف أنا أبغى أتدرب عليها يعني في مثلا أبغى أرجع حين مع نفسي.
Well, I'm teaching you now how to do it.
I want to do it with myself, to practice.
Put numbers, connect two circuits together, same voltage. Okay? So we finished all the modules except the last module, power converters. You're free to go. It's 51. We'll talk about it next week.